Okay, welcome back. Welcome to lesson 9.1. Let's see if I can make this a quick video. I hope so. Okay, so in lesson 9.1, we're going to be talking about operations with rational expressions. And when I'm saying operations, I mean plus, plus, minus, times, and division. Okay? We're going to be doing all four of those together. Yeah? And so I'm looking at a few problems that go through these operations. Now, really, as far as teaching, there's really not a whole lot new here. But what this is the amalgamation of many things you've learned prior. Okay? This is just a ton of Algebra 1, Algebra 2 stuff all coming together in one setting, which is rational functions. There's going to be more complicated factoring from here on out for the rest of the year. So our factoring skills are going to be pushed a lot harder. And it's all fractions. It's all manipulation with fractions, constants, variables, and the like. So you have to get comfortable with that. However, the basis for multiplying fractions and adding fractions is the exact same, as you know. And all of these factoring rules we've covered before. So really, it's just a matter of remembering a bunch of stuff you've already learned and putting it together in one setting. Okay? Now, real quick, before I begin any of these examples, here's a quick reminder on multiplying and dividing. Okay? If I have a over b times c over d, right? If you're multiplying two fractions, that's the same as you just multiply the numerators, a times c, and you multiply the denominators, b times d. Nothing more to it, okay? So if you have 1/2 times 1/3, that is, or maybe I'll make it like 4 halves. Oh, that's 2. Come on, Mr. Spig, let's try it. How about 5 halves times 1/3? That'll be 5/6. Yeah? You just multiply numerators, multiply denominators. That's how multiplication works. If you have a over b divided by c over d, so got two fractions, then the rule is keep, change, flip. Keep the first fraction, change it to multiplication, and flip, take the reciprocal of the second fraction. And then now it's just a multiplication problem again, right? AD over BC. So there you go. And notice it's kind of like cross multiplying. A, D, B, C, kind of like that. But be careful because it's not cross multiplication, so don't interpret it that way. It's just similar to it. And then let's say I'm going to erase this. Say A over B plus C over D. Now I could put a plus or a minus here because all minus is just negative. You're adding a negative. So the rule is kind of the same here. When you add or subtract fractions, they have to have a common denominator. You see, I can't do 1/2 plus 1/3 is 2/5. No, never. I got to get a common denominator. I got to make that 3/6 and 2/6 and add that to get 5/6, right? Notice once I find a common denominator, I'm not adding that. It's just that's the denominator now, and I'm adding the numerators to get that. So you know this. You don't need me to explain all this, but it's just a reminder that these are our rules, and that's what we're going to be doing. And they look different now because they're in a new context, but I'm telling you, you know this. You already have learned this for years with fractions, okay? And by the way, if you were to add these guys together, that result would be a over b times d over d plus c over d times b over b. And the end result would be AD plus CB over D or BD. Okay? That's how you add those fractions together if you were general form like that. Okay, let's actually do some examples so I don't keep wasting video time. Here we go. We are going to analyze this. I'm sorry, wrong word. Not analyzing, we are simplifying. And that is all we are doing in this lesson. We are just simplifying. So, key to simplifying, factoring. you want to factor your polynomials and your expressions to see if there are any common factors on top and bottom that cancel. This way you can simplify, all right? Yeah, that's pretty much it. So I'm going to factor everything that I can. So if I look at the numerator of the first expression, right, this one, 3y is just 3y, nothing to factor there. 2y plus 2, I see a greatest common factor of 2, so I'm going to factor 2 out, and then times. And now I'm going to factor the numerator, I'm going to factor the denominator. To factor the numerator, it is, that's a, that looks like a perfect square trinomial, actually. X minus 4 squared over, and then here it looks like the GCF is 48 divisible by 3? I think it is. 3 goes into 48 16 times. Yeah, so I see a 3 that I could pull out, and they also both have y's, so I'm going to factor out y as well. So I'm going to actually factor out 3y, and I'm left with x squared minus 16. And then let's just go ahead and let's factor that last piece. So I'm going to circle, let's say this guy. That actually is a difference of squares, so that factors as x plus 4, x minus 4. Okay? So if I write all of this as one fraction, because remember the rule for multiplying fractions is you just multiply the tops, you multiply the bottoms, right? So the numerator is going to be 3y times x minus 4 squared. I'm going to go ahead and write it as x minus 4 times itself. You don't need to do this, but I am writing this to illustrate something for you. And then this is 2 times y plus 1. And then I need to use some parentheses here, 3y, and then x plus 4, x minus 4. And notice the reason I did this is, let's see, if you use this 3y up here, notice there are things you can cancel. 3y divides with 3y. X minus 4 divides with x minus 4. And so that's all that cancels. So let me switch back to red. All that is left is in the numerator, x minus 4. And in the denominator, it's 2 times y plus 1 times x plus 4. And that's it. That's done. Sorry, I want to put on Do Not Disturb. Okay, finished. There's nothing else to factor. We can't simplify it any further, so box it, call it a day. Okay? All right. Let's move on to example 2. And now we're just doing a division problem, but remember, to handle division of fractions, just use the keep, change, flip rule. We're going to keep the first fraction, x cubed plus 8 over y squared plus 6y plus 9. We're going to flip it, change it from division to multiplication. And then we're going to flip, meaning take the reciprocal of the other fraction. We're going to put 3x plus xy on top. And we're going to put x squared minus 2x plus 4 on bottom. And now we're back to a multiplication problem. So let's just factor. Now, x cubed plus 8, that's a sum of cubes. So I can use the sum of cubes identity. X plus 2 times x squared minus 2x plus 4, using the sum of cubes identity, over, and now the denominator is a perfect square trinomial, so this is y plus 3 squared. That's how that one factors. It's too many. It's y plus 3 times y plus 3, yeah, times, looks like I can take a GCF out of the top as x, and so what is left behind is 3 plus y, over, and now I look at that last factor, x squared minus 2x plus 4, well, if I do a little cross puzzle real quick, 4 and negative 2, I'm not sure you can find anything that satisfies this, right? Because 4 and 1, well, that's not going to work, and neither is 2 and 2. So that part is actually not factorable, so we need to leave that alone. and just have it like that. Okay. And now I notice a few things. I'm going to go ahead and rewrite the fraction. You don't have to do this, but I want to do this so you can really see it all together as one single fraction. I'm going to write x plus 2, x squared minus 2x plus 4, and then x, and then 3 plus y, and then, again, I'm going to expand that so that it's, or rewrite it so that it's y plus 3 times itself. And then that last factor, we could not factor. So we keep it like that. And I want to see what cancels. Well, 3 plus y on top, that is y plus 3, which means it's going to cancel with one of the y plus 3s. It's not going to cancel both, right? It's only dividing once. But 3 plus y is the same as y plus 3, so that's going to cancel one of them. I also noticed that this irreducible quadratic here cancels with that irreducible quadratic on top as well. So both of those are gone. And so I am left with x plus 2 times x over y plus 3. And that's finished. I might, just because I like to write it this way, I might write this as x times x plus 2 over y plus 3. That's just a me thing. Okay, look, if you if you wrote it as the thing up above, that's fine. It's correct. Okay, nothing. It's fine. Woohoo! Look at that. So you see, it's just factoring, right? You just factor a bunch of stuff, and then you use the keep, change, flip rule for fractions, and then you just multiply, and you cancel any common factors on top and bottom. All right. Let's move on to some addition subtraction problems. So for addition and subtraction, you have to get a common denominator. Now, it's important, in order for you to find this common denominator, you need to factor. You have to factor, really, because otherwise you just won't be able to know what you need to multiply the numerator by to make it so that, or what you need to multiply by so that the denominators are all the same, therefore you can add them together. So we're going to start this first one by factoring. Nothing to factor in the numerator, it's just 2 over 9x squared plus 42x plus 49. Let me tell you what not to do. Do not do 9 times 49 and try to make a cross puzzle out of this. That is atrocious. Rather, instead, recognize that this is a perfect square trinomial. You see 9x squared plus 42x plus 49. 9 and 49 should be sending red flags to your brain because 9 is 3 squared. So 9x squared is 3x quantity squared. 42, well, I'm going to write it this way so you can see it. That's 2 times 3 times 7 times x. And then 49, or maybe perhaps, let me write it like this. 3x times 7. That's probably better. Okay? And then 49 is 7 squared. This is a perfect square trinomial following the pattern a squared plus 2ab plus b squared factors as a plus b squared. I just wanted to show you that because I know you might be confused on this one. So this is going to factor as a is 3x and b is 7. And we are squaring that. Okay? So that's that one. And then let's look at the other. Plus 4 over. Now, this is a basic a is not 1 case. So if you want to use your cross puzzle, you say 3 times negative 14. Oh, what is that? That's 6, it says negative 42. And that's 1. 6 and 7, I think. 6 and 7, where 6 is negative. Now, if you want to do kickback method to be really quick with it, you could just say 3x, it'd be like x minus 6 over 3, and then x minus 7 over 3, and then you just kick it back, so it's x minus 2 and 3x minus 7. And that, kickback method, that's fine. Or you can do factor by grouping. This is just a quick review. If you want to do 3x squared minus 6x plus 7x minus 14, and then factor out the GCF, 3x x minus 2 plus 7 times x minus 2, and therefore you get 3x minus 7 and plus and x minus 2, like so. I just worked it two ways, but I just wanted to remind you real quick of the multiple ways you can factor this. You can also do guess and check. Guess and check is pretty effective on this one. Okay, so now I need a common denominator. Now, to find a common denominator, I guess if you want to do brute force, you could just multiply every denominator times every fraction that you have. But that, no. Look for what's called the least common denominator. Least common denominator, which is the LCD. LCD. Okay, boop, boop. Well, the least common denominator is, it's just, well, it's the smallest denominator that you need, really, right? That's kind of basic terms. If you had 1/2 plus 1/3 plus 1/6, the LCD is 1/6. You don't need to put this in terms of twelfths or 24ths or anything like that. Sixths is the smallest number you need in order to be able to add all of these up together properly. So what you want to do to find the least common denominator is just think about how many factors you need. You just look at your factors and you think about what's missing. So if you look at our first denominator, which is right here, I know that I need 3x plus 7 squared in the denominator, right? So I need that. And then if I look at this denominator, I need a 3x plus 7 and I need an x plus minus 2. Well, the thing is, this squared already includes a 3x plus 7, right? Because this is 3x plus 7 times itself. So one of those is already included. So I don't need to add another. But I don't have an x minus 2, so I need to tack that on. So I put an x minus 2 here. So that's what my least common denominator is going to be. So I know that the fraction overall is going to have a denominator 3x plus 7 squared times x minus 2. And now it's just a matter of multiplying the numerators to match that. Yeah. So this numerator, right, I need to, if I'm looking at this, if I want to make this denominator the LCD, I need to multiply by that chunk, which is x minus 2. And I need to do that on top and bottom. So you see, what's going to be in my numerator is 2 times x minus 2. So that's 2 times x minus 2 plus, and then the same exact idea. Here's 4. This is the denominator here. It has the x plus 2. It has one of the 3x plus 7s, but I need 2 of those, right? There are 2 3x plus 7s, so there needs to be another 3x plus 7. That way it matches the LCD. So I'm going to say plus 4 times 3x plus 7. Yeah, that seems right. Okay, cool. I was just doing some mental thinking. Let's distribute this and combine like terms. Maybe something will pop up. So distribute the 2. I'm going to get 2x minus 4 plus, let's distribute the 4. I'm going to get 12x plus 28 all over. Now, you do not need to expand the bottom, okay? Do not bother doing that. It's fine. The reason I'm expanding at the top is because, well, I have some plus signs up there. I can distribute this and combine it and simplify it, okay? Because I have like terms that are kind of hidden in there. 2x plus 12x is 14x. Then this is what, plus 24 over 3x plus 7 squared, x minus 2. Looks like I could factor out a 2 if I'd like. not super necessary, but it's good to check and see if there are any common factors, because who knows, if I got a 3x plus 7 up top again, I could cancel that with one of the denominator factors. But there it is, like so. Yeah, cool. Looking good, I think. Yeah. Okay, so I was just double checking. All right, last one, example 4. Here we go. Same exact idea, but now I'm adding together 3 fractions, so I need a common denominator. So let's identify that LCD, that least common denominator. I know that this first denominator, I need an x plus 1, so I'll put that there. Now, this denominator is x plus 1 squared, so that's x plus 1 and x plus 1. So I need 2 of these. So let's actually tack on another x plus 1, and then I need an x minus 1 on the last one. And that's going to be my least common denominator. Okay. Notice, I don't need 3 of these, right? I don't need x plus 1 cubed, because x plus 1 squared contains x plus 1 as a factor already. So no need to do that. So now, to add these fractions, I'm going to put it all over the least common denominator, which is x plus 1 squared times x minus 1. And, well, now we just need to multiply our numerators by whatever's missing. So this 1 is going to be multiplied. Let's see, I need to make this denominator, the LCD, I need to multiply this by another x plus 1 and an x minus 1. You see that? I need both. So it's going to be 1 times x plus 1, x minus 1, plus 1 times, and then this one has the x plus 1 squared, so this piece is good, but it needs an x minus 1 on top and bottom. So it's 1 times x minus 1, and then minus 1 times, and then, of course, this denominator already has the x minus 1, so that's good, but it needs it needs both x plus 1s, so I need to do x plus 1. You can either write x plus 1 squared or x plus 1 times x plus 1. I'll just do squared. Okay, so we want to expand the numerator, because there could be like terms here that we want to combine. You don't need to expand the denominator, though. It's already perfectly factored, and the goal is to simplify it to look for factors that cancel. So you're not doing yourself any favors by expanding the bottom. Now, that first piece here, x plus 1, x minus 1, that's a difference of squares. So I know that's x squared minus 1 plus, this is just 1 times x minus 1, so that's just x minus 1. And then it's minus, I want to put this in parentheses. You see it's x plus 1 squared, right? This is x plus 1 squared that I'm subtracting. So if I expand x plus 1 squared, so this guy, x plus 1 squared is x squared plus 2x plus 1. So that's actually what I'm subtracting here, x squared plus 2x plus 1, all over x plus 1 squared times x minus 1. Okay, let's combine like terms. I see x squared, I might need more space actually, let me go left. X squared minus 1 plus x minus 1. Distribute your negative here to all 3 terms. Minus x squared minus 2x minus 1 all over that common denominator. And now just combine. So I see that x squared and negative x squared cancel. And then I see I got a negative 1, a negative 1, and a negative 1. Okay, so I know that that's a negative 3 if I put all those together. And then I have this positive x minus 2x. Well, 1x minus 2x is negative x. And so I have negative x minus 3. I like to factor that negative out and keep x positive. So I'm actually going to factor the negative out and write that as x plus 3. And then that's over the LCD, which is x plus 1 squared times x minus 1. Something like that. Okay. Whew, there it is. And so that is finding all of that business. You see, you know all this algebra. You know how to factor. You know how to find least common denominators. It's just a matter of practicing it now. And we're spending a whole day on this because, one, there's more complicated factoring techniques, so you gotta practice those again. And you just got to practice this fraction math stuff, okay? And yeah, so that's it for the video, pretty much. You have remember the 5th of November or whatever that rhyme is. Class link. You have a quick homework to do, okay? Go do this, yeah? It's 4 questions, okay? Simplify that expression, simplify this one, simplify that one, and identify the least common denominator of that one. So you don't actually have to expand that one. And then give me a quick reflection on what you learned and what blah, blah, blah. Okay? All right. I hope this video was short, concise, and informative enough. If you got questions, bring them to class. Write them down in your journal. Let's talk about it. All right. Thanks for watching, and I'll see you guys later.